Thanks all for being here. Yeah, so this one will be a bit more about applications, especially compared to the other ones, I guess. But I hope you all enjoy it. So today we will talk here about these three farmers here. You see here, they're probably somewhere in Rwanda. And they have fields, well, you can barely see them, the small fields, that's like their complete plot. That's their 1 acre. And it's my job always to try to support them with data science. And well, by doing that, we encounter a lot of struggles, and I hope to take you on this journey to show you how to overcome some of the challenges at least. So this is me. I work as a data scientist in One Acre Fund. Here I'm in Zambia on a plot talking with a farmer and a local colleague. This is a maize plot, and we're actually not talking about the maize here. We're talking about the trees that you can barely see, and about the project, how we were going to identify them with satellites. So you can already see the challenges if, like they're barely visible on this picture. So the problems that we will have when we are identifying them. So I will give a short introduction about the organization I work for, just for you to understand what we're doing, and also for the data science cases to make sense. Then we're going to talk through different issues, like where's the farmer, is there information available about the farmer, how is the farmer actually doing, and what should the farmer do, how can he or she, or mostly she, improve the farming best practices. So this is One Acre Fund. We are in basically all of Eastern Africa, and it's very depending on which country we are, where the kind of stuff we do. So this is actually in Kenya. We see a duka, which is Swahili for store, and people can come here to take their inputs. While for other countries, we actually go visit them. They often even don't have any means to go to a store. So, but in Kenya, this is the more prosperous one. You can, I don't know if you can see it, but there's actually like solar panels they can get, or fertilizer. And we support the farmers with different kind of products, with seeds, fertilizers. We give them trees. Sometimes trees are like cash crops, so that's mangoes, avocados that they can then use to sell. But sometimes more for carbon credits. We give them microcredits, so they get funding up front and they repay later on. They can get insurance, and we give them a lot of recommendations on how to plant, the crop health, the soil health, and basically in all of these steps, data science can add a lot of support here for the farmers. And the farmers, we are on this journey with them, like it's a typical, I think it's from the World Bank that you categorize farmers or people into 4 stages of prosperity, where they go basically from hunger to prosperity. Prosperity is like if you have an Italian farmer, he's there, his kids can go to university. But we focus mostly on the hungry farmer, who's really struggling just to make ends meet. And by just improving their yield, they can at least go from hungry to self-sufficient. And then they can feed their family, the kids can maybe go to primary school. And then after they made it there, we're also helping them, especially in the more developed countries, to go to advanced farmer, like they can have really money to send the kids to a proper school. They can have money for maybe a motorcycle to really get themselves somewhere. He's healthy. If he has troubles, he can go to the hospital. And going from step self-sufficient to advanced is a completely different story than going from hunger to self-sufficient, because then you're actually thinking about actually how to add money to the farmer. So like cash crops and exporting nuts or avocados, mangoes. So we operate, as I said, in almost all of East Africa, but also in Nigeria. We serve 4 million farmers. We started, we were so proud in 2019 when we had reached like 1 million farmers, and it's still going up like that. And we generate $200 million of profit. And it's already the first data challenge, like how do you measure like the impact that you're having? So what we do, we have farmers and we have control farmers who are not with us. We compare basically the yield, the profit that they make, and that's the impact. So we have impact per farmer, and then we have the amount of dollars that the donor needed to give to the farmer, and then we have the SROI, which is, so it can be up to 7.5 for Rwanda. So every dollar someone donates is actually adding $7.5 to the Rwandan farmers. Well, like for every dollar you donated to Tanzania, it's actually only adding 0.9 to the farmer. So we are, sometimes that happens, and then we have to take, well, basically slowly shut down Tanzania and maybe try something else. And overall, the impact is going quite up. So I think now it's about $3.5 for every dollar donated. And then, so how can data science and remote sensing help for this farmer? Well, we can help them with monitoring how they're doing. So we can monitor how the trees go, also to monitor deforestation around the plots. We can monitor how well the farmer's yield is doing. Like, yeah, like with this colorful plots, you can even, at least in the West, for the bigger plots, you can even tell like which areas of the field are doing well and which can maybe use extra fertilizer, extra lime, stuff like that. And then we can also help them with improving their efficiency. So we can use data science and Python to track like the trees, to monitor them, like, okay, where are the trees, identifying them, seeing how big they are. And then we can say, okay, this kind of trees, if it's this big, then it's actually the equivalent to this amount of carbon credits. So you should be rewarded this and that. Monitoring floods, so if a farmer is in a flooded area, maybe he gets an insurance, or maybe we can forgive a loan so he doesn't need to struggle, maybe kill his cow or something like that to make ends meet and to repay. And maybe it's better for everyone if he would just wait another season. We can tell him when to plant, also what kind of things to plant, fertilizer recommendations, and sorry. Yeah. And for that, we first have to know where the farmer is and what is the field of the farmer. And this is more difficult than you would think. Like for most of the farmers, we actually, like 3 years ago, we didn't have a single clue where they are. Like, okay, they would come somewhere to pick up, they would walk somewhere, pick up the goods, and then they would leave again. So I'm sure someone knows where they are, but I don't actually. And they could be like 10 kilometers from the point where we would give them. So then we were thinking, okay, maybe what we can do is we can do some automated fields delineation. So then we can create the fields, and then we can ask them like, hey, where are you? Can you point to your field? And then we can put that in our database, and from then on help you with recommendations. And yeah, because in the end, as I said, we have like 4 million farmers, so it's quite a task to go and walk around maybe the plots, visit them all. So we went to do something with, we worked together with Berkeley with a fractal ResUnet, and it's encoded decoder architecture. And in the end, we try to predict the extent, which is basically the inside of a plot, the boundary, which is the border of the plot, and the distance. And the distance is like 1 if it's the center, and 0 if it's the boundary, and also 0 if it's outside of the plot. And well, when doing that, we had a lot of challenges. Like one of the things is that we don't actually label all fields, of course, because we can only label our own fields and not the farmers that we actually don't know. So we fixed that by evaluating only the labeled fields. So by evaluation, we would skip just the whole area that was not labeled. And we were also not sure about how many labels we needed. So we did some testing there, and then we asked, we sometimes ask people to label a few more, maybe by hand, on a satellite image. And of course, as you can see, sometimes the fields are just too small, like we don't even have pixels, like we don't have the information to identify it also by visual eye, you couldn't fix it. Sometimes it's a low contrast, so if you think about the one where I'm standing with the trees, The problem there is that just he stops like somewhere on the plot. So where is actually the end of the plot? How does that work? Sometimes it's more arid location. And we had used different metrics. So we used overall accuracy, F1 score. And the one we really tried to optimize is the MCC. And for every plot, you can see how well we did by comparing the area of overlap with the area of union. And so then we were almost there, and then Google actually showed up and they said, hey guys, can we do it for you? We have all these GPUs. And so we ended up doing that, but it's theoretically it's the same. And let me show you how that went in the end. So for this, we built our internal streamlit app. And sorry, let me, yeah, I can put it there. So, okay, we created this streamlit app. It's in Dataiku, so you'll probably see colleagues logging in and stuff, but it's something we can ignore. And let me see, let me get their plots. And let me also get some labeled fields that we can zoom in on. And let me just select one by ID. And then we can see how it went. And maybe I should change this to satellite just to make it more interesting. And as you can see, this already went quite well. Like we see the different fields that are labeled there. So you can see the boundaries, and you can see that the boundaries, and I can maybe sometime like toggle this. Yeah, you can see actually that it's not one field, but at least it's like 8 fields or something that are labeled quite well by Google. So then in this case, we could maybe go to the farmer and ask like, okay, it's apparently not 1, but we have found 8. So can you tag all the ones that are yours? And then that way we can, we can know where you are. But it's actually not that possible because you will see that he also missed some of them. So, okay, we did a really cool data science stuff, but it's actually quite useless. like we can't really, we still don't have an approach really how to do this now. So, but one thing we figured out is that we can ask them how to walk around the plot, and then afterwards, like map it and see where it doesn't match and see how we can overcome that problem, and hopefully also for a lot of farmers at least have it then correct, like be like, okay, these ones are all correct, let's just use the lines that were found by Google in this case, and for the other ones, let's just maybe walk around it again or something like that, or maybe just go for what they've walked around. Then there's also point detection, like for the trees, we want to know where the trees are planting. This is a horrible story altogether again, because often they don't have proper devices to do this. We don't have the capacity to give them like the Garmin devices, and even they have like have like a meter or accuracy or something like that problem. So it's still, if you're a meter away from the tree and you've seen the trees are very small, then you're quite far off the tree actually, and it's quite useless the way you tag them. So we're trying different ways. We try different approaches to ask them, like, okay, can you maybe tag the tree 5 times or 4 times or 3 times? And then by using some logic about the accuracy, often it does give you the accuracy and can tell you how far it is off. And also by combining them, we could see like, okay, what is the best strategy and what will work best. So 5 points, you see that they just become impatient and just start button bashing before it's even accurate. So especially with the green one, is really just opened it and started. So that's doesn't work. So then there's 4 points and 3 points, and the convenient thing with 4 points is that you can take the one that is furthest off and then ignore that one, and then you end up with this one. And this is actually quite accurate, and for this one at least you know for which ones you're off, and for the ones where you know you're not off, then you actually identified quite properly where the trees are. So this is what we're doing at the moment. And now we know where the farmer is, and well, then the next step is to actually start doing some data science. So for that, we used Google Earth Engine. I'm not sure if are there people familiar with Google Earth Engine? So it's like 2 years ago, we were not using Google Earth Engine. We were doing everything by hand, working with universities, trying to collect all the information manually. And yeah, that was a hell of a job. It was like a full-time job to really make sure that the data was all the time accurate and up to date, and that the servers didn't break. And so then we moved away from that and started using Google Earth Engine, where you really can collect all the information that you need. And like, for example, one data set we use often is ISDA. ISDA is information about the soil. So it gives you information about, for example, pH is an important one for us. Here we go. So pH, but also nitrogen, and basically whatever you want about the African soil. And it's really quite easy to use. They work quite well. The descriptions are there. They tell you like, okay, these are the 4 bands that basically the raster uses. And they give you some example code that you can run to visualize it in a way that makes sense, depending on the source you use. And then you can actually, like, we're doing this on the fly, you can run it. And then it's just there. We have this interactive map of all of Africa giving us where what the pH value is of every point of land. And sorry about this. And there's also, for example, deforestation, which is really important for us. You can plot the deforestation and you can see where the forest was removed. And this is not only available in their JavaScript viewer, but it's also possible to just, by really using only a few lines of code, to have a map spin up. And then, for example, this is a split map. I hope this... and really easily we can spin up the streamlit. So it's GEE map is the package you need. And then by just these few lines of code, we now have like this split map, as I said. So, sorry. And you just do it by importing EE, which is Google Earth Engine, and then EE.authenticate. And then you just need to get your authentication somewhere, and then you can start using it in Streamlit or wherever you want to use it. You can also, instead of just using like the visuals to see what's going on, you can also create more like a flow that it integrates with pandas or geopandas in this case. So where you just tell him, like, okay, I want to have the deforestation image. Okay, let's change the GeoDF to Earth Engine. And then we can just select the loss and reduce it. And we have a GeoPandas data frame, but now with added to it the deforestation. So if you have a geo data frame of all the farmers, then from now on you can know really for all the farmers if they were involved in deforestation or not. And so we do that a lot to do it like that. So we often collect the information in Google Earth Engine, then we transform it to a data frame, and then we have a data frame that we can actually run the models on, just like we used to, just with scikit-learn and stuff. I think it also integrates with their own Google products, but I prefer just to use it like I'm used to. And then if we have predictions or something, what we often do is turn it back into a raster file again. So we turn it back into a file. that can be accessed, and then we deploy it. And we deploy it to API endpoints, and that way someone can come in, just give you a latitude and a longitude. And then, for example, with a Lime recommendation, you can just tell them like, okay, your location is here, and for this person, we recommend no Lime. Or we recommend this kind of seeds. Or even for rainfall, we have like automated, like we run the same script every day, and then we have new planting date recommendations where we tell the farmer like, hey, rain is coming your way, maybe you can start planting tomorrow or something. One thing with the yield, what is always important is the NDVI or the EVI, but it's basically how green the picture looks. So if you want to know like how the maize is doing, you take the images and then see how green it is, and it's often an important indicator for how well the farmer is doing. But as you can see, we're always collecting a lot more information about the fields, just things that we can collect with Google Earth Engine and then extend it that way. And one final challenge that we had for a long time was really like, okay, if you have all these API endpoints and stuff, then how are you gonna tell the farmer when to plant? Because if you don't know where he is and you're doing everything on paper, it's quite nice that you have all this cool data science, but it's still not feasible to actually help her in any way. So throughout the years, it became more and more possible to support them with the advanced technology. In Kenya, we are able to build apps, and we integrate with the apps with the rasters that I shown, and we can give them real-time advice. But for a lot of other countries, it's possible to use USSD. I'm not sure if people are familiar with that technology. It's if you have a feature phone, you can send an SMS. Some of you might have known it's like star, then you give a code, you do a hash, then another thing pops up, and it's bidirectional. So you don't need a smartphone for this. You're basically using an app, but by just sending text back and forth. And that way someone can go to our like star, I don't know, 118 star, 1 hash, and then he can ask, and then he will get the answer like, okay, plan tomorrow, something like that. So he doesn't even need a smartphone for that. So with limited resources, he can still then access like all this satellite information and know what are the best practices. So are there any questions? Yeah.
Thank you very much for the talk. And yes, we have a lot of questions. And the first one is, what geodata format do you love most and why?
So I think GeoPandas works well as like as when you're working with data frames, and now we use Google Earth Engine for the rasters, so we're actually not really touching any rasters themselves anymore. But before we use that, we used Raster.io, which worked really well. Yeah. So and then often you don't really have a choice on which kind of formats will come your way, the raster files, because there's like crazy amount of formats out there, which are all very similar, if you ask me. So then the TIFF files work best, I think. It's my experience, but yeah.
Cool. Would you recommend switching over to Dataiku? I don't know what it is.
It's okay. This is maybe not really for this conference, but yeah. Yeah, but it's not, okay, it's not really, my answer is not really fair, because we are an African NGO, so they give us everything for free. So if you get it for free, yeah, I would definitely recommend it, but I don't know about the cost. But the tool is really, so we still do everything in Python. It's very Python oriented, so it's definitely not something that would replace your coding and stuff, but it really helps me with a small team, like the small team show that we're running. It's definitely would have been impossible without a tool like this. Yeah.
The next question is, how long do you normally work together with a farmer?
I
think it's a matter of collaboration. How long lasts a collaboration with a farmer?
How does that work? So the stores that you've seen before, like in Kenya, there people can just come in and take something and then move, but it's not typically something we do. It's mostly a multi-year thing where people signed up, they repay during the season, then they collect, and often there's also some perks for them, like if they basically advance to the next year, they can get more credit, for example, because they turn out to be trustworthy. So yeah, there are many farmers who are there for like 15 years already or something. Yeah.
Wow. Which remote sensing do you also register trees being cut, burned after carbon credit allocation, and have a policy to deal with that? It's a complicated question.
Well, I don't think that. Yeah, it's a good question. I think they register. Yeah, I think I don't actually know the answer to this question. Okay, less from a carbon credit specific point of view, but more from improving the world. I think it would still be like the trees that you saw there. They're planting there. They're giving moist to the soil. They even fix nitrogen and add it to the soil. And if the farmer decides to, well, it's actually part of the plan that the farmer cuts it down and then starts burning it, because they're using charcoal anyway to cook. So they might as well plant their trees and then cut it down instead of going to the rainforest and get it. So yeah.
Makes sense. And are there any security or privacy concerns for the resulting application?
Well, the nice thing about using open geospatial data and stuff is that often you don't have to worry about that a lot. Like someone can just give you like a GPS coordinate, and then you can give a recommendation on I don't know what. So we don't have to worry about that much. And yeah, I don't see any, but maybe.
All right. Who owns the data? Mostly the same question. The farmers are at or 1 Acre Farm?
Yeah, so that's a good but very theoretical question, I'm afraid. Like if you're a farmer on that hill, you're not like the right to be forgotten and stuff. It's the GDPR is often there in a lot of these countries. They adopted like the European rules. But if you're a farmer on a hill, do you own data? Yeah. I'm sure theoretically it's like that, but I think it's maybe more a discussion for the future. Yeah.
How bad is it when you don't detect the whole farm plot? Aren't your advices and crop prediction already 80% useful?
Yeah, probably. Yeah. But then you can also wonder if you just tag like the center of the field, if that would not be enough. Like that, definitely for a lot of use cases, it adds already a lot of information. So we are actually doing that. Like we are like, okay, even if we're not completely accurate and stuff, let's just go, because 80% of my use cases will still work. But but if you really want to use it for insurance, for example, then you really have to know, like, okay, is this area flooded or not?
Do you use Google Maps satellite view or have other providers like Maxar?
We use mostly, well, okay, here this was just OpenStreetMap and built-in stuff from Streamlit. That's just there, but just to visualize it. But if I really want to know, like if I want to check how green a field is and stuff, you can't really use that because, I think we already reached the Zoom level where it's like, okay, like it won't work. So there's especially initiatives from the Norwegian government that open. If you're in Africa, you get a lot of stuff for free. So then, so there's really high resolution images available, paid for by the Norwegian government, and we use that.
Okay, we have finished the time at our disposal. So thank you very much again.
Thanks.